Ever wonder what keeps a speeding train from, like, derailing on a curve?
Yeah.
Today's deep dive is anything BUT off the rails. We're tackling railway design. Buckle up, because we're about to uncover the fascinating engineering that keeps those journeys smooth and safe.
Right.
All based on excerpts from this track layout document.
Yeah, it's easy to take for granted. I mean, every curve, every incline, it's all, meticulously calculated.
Okay, so let's say we're hurtling along at a good clip, approaching a bend. What's the magic that keeps us from flying off into the sunset?
Well, it's not magic. It's physics and clever engineering, right?
Right.
As a train rounds a curve, you've got centrifugal force. It's trying to push it outward.
Oh, okay.
That's where cant comes in.
We can't, like leaning into it.
Exactly. The outer rail on a curve is actually higher than the inner rail.
Huh.
It looks subtle, but that slight tilt, it counteracts the centrifugal force, keeping the train stable.
Okay, that makes sense.
Yeah.
But it can't be as simple as just tilting the track and calling it a day, right?
You're right. It's actually way more precise than you might think. The degree of cant has to be calculated very carefully. It's based on the train speed and the radius of the curve. The faster the train or the tighter the turn, the more cant you need.
So there's like an ideal angle for every curve and speed, like a Goldilocks zone for train tracks.
Precisely. And this is where things get really interesting.
Okay.
Passenger trains and freight trains, they operate at very different speeds.
Right, of course.
So designing for both on the same line, it's a balancing act.
Yeah, I bet. Too much tilt for a slow-moving freight train, that wouldn't be great, would it?
Not at all. Excessive cant for slower speeds, it means more wear and tear on the tracks.
Oh, right. Makes sense.
Not to mention a less than smooth ride.
Right.
But too little cant for a high-speed passenger train, get ready for a bumpy ride.
So how do engineers find that sweet spot, that perfect balance between, passenger comfort and freight efficiency?
Compromise is key.
Yeah, right.
Our track layout source uses terms like cant deficiency and cant excess.
Interesting.
To describe those situations where the tilt isn't quite ideal for a given train, they're constantly juggling these factors to get as close to optimal as possible.
Cant efficiency, cant excess, I'm adding those to my vocabulary. But it makes you realize that a lot of thought goes into something as, simple as a train ride.
Absolutely. And we haven't even touched on how you transition between those curves.
Oh, right. It'd be pretty jarring to go straight from a straight track into a sharp curve at top speed.
Exactly. And that's where these brilliant things called transition curves come in. They're like the unsung heroes of railway design.
Transition curves. Tell me more.
Imagine easing into a curve, like merging onto a highway. You wouldn't want to make a sudden sharp turn at full speed, right?
Right.
Transition curves are gradual, subtle shifts in curvature that make for a much smoother, safer ride.
So it's all about making those transitions as seamless as possible. I'm guessing there's a lot of math involved in designing those too.
You bet. These curves are often based on complex geometric shapes like cubic parabolas and clothoids. These shapes have gradually changing curvature, making them perfect for smoothing out those transitions between straight sections and curves.
This is blowing my mind.
Right.
It's amazing how much goes on behind the scenes to make our train journey so comfortable. But what about changes in elevation? Surely hills and valleys present their own set of, design challenges.
You're thinking like a railway engineer now.
Uh-huh.
You're right. It's not all about horizontal curves. Changes in elevation, what we engineers call gradients, they add a whole new layer of complexity.
So we're talking hills and valleys. That's got to
Right.
impact the train's speed and, energy use, right?
Absolutely. Steep inclines mean more power is needed to pull a train uphill,
Yeah.
and controlled braking becomes crucial on the way down.
Yeah, makes sense.
And just like with those horizontal curves, smooth transitions are key. That's where vertical transition curves come in.
Vertical transition curve. So instead of abrupt changes in, slope, it's a more gradual incline or decline.
You got it. These curves, often based on similar mathematical principles as their horizontal counterparts, help to smooth out the change in elevation. This makes for a more comfortable ride and reduces wear and tear on the tracks and train.
It's incredible how much thought goes into these details that most of us never even consider. It's like this hidden world of engineering precision. But I'm curious, this track layout document, does it talk about the environmental impact of all this at all?
It absolutely does. It's not just about physics and geometry. It's about, weaving these railway lines into the existing landscape with minimal disruption.
Because it's not like we can just lay tracks wherever we please, right? There are ecosystems, communities, all sorts of factors to consider.
Right. Our source emphasizes minimizing noise pollution,
Right.
especially in areas near residential
Oh,
communities.
yeah, of course.
Imagine living next to a high-speed rail line without those
I
considerations.
can't imagine. And then there's wildlife too, right? Train tracks often cut right through their habitats.
Exactly. That's why designers factor in wildlife corridors,
Oh, interesting.
safe passages built over or under the tracks, allowing animals to cross without, risking a collision.
It's like building a bridge for the local deer population.
Haha, exactly.
It's fascinating how interconnected all of this is. The physics, the engineering, the environment.
It's a delicate balance for sure. And beyond the practical aspects, our document even mentions aesthetics.
Aesthetics, as in like making sure the train tracks look pretty.
You could say that. Designers consider the visual impact of the railway on the surrounding landscape. They'll incorporate landscaping, use natural materials where possible, even think about the views from the train windows.
So it's not just about getting from point A to point B. It's about making the journey itself as pleasant as possible for everyone and everything involved. I never would have thought about that.
It's all connected. And speaking of innovation, our document hints at some cutting-edge developments in railway design. Have you ever heard of tilting trains?
Tilting trains. Sounds like something out of a sci-fi movie. What's the deal with those? They do sound pretty futuristic.
They're becoming more common in modern rail systems. These trains can actually lean into curves as they navigate them.
Like a skier carving down a slope.
Exactly. This tilting action, it allows for higher speeds on curves without sacrificing passenger comfort. It's a win-win, really, for both speed demons and those who prefer a smoother ride.
Sign me up for both.
Ah.
What other innovations are shaping the future of railway design?
Well, our track layout document also mentions the use of computer-aided design, or CAD.
CAD.
It's revolutionizing the field.
I know it's used in like architecture and manufacturing, but for train tracks too.
Absolutely. CAD allows engineers to create these incredibly detailed 3D models of railway lines.
Right.
Before any physical work even begins, they can test different layouts, simulate train traffic flow, and even analyze potential environmental impacts, all within a virtual space.
Wow. So it's like they can work out all the kinks and optimize the design before laying down a single track?
Precisely. It's a game changer for efficiency, safety, and minimizing those unforeseen challenges.
Yeah, for sure. This deep dive has been quite the eye-opener. Who knew railway design was so complex and fascinating?
Right.
I'm looking at train travel in a whole new light now. It's like this symphony of physics, engineering, and environmental consciousness,
Yeah.
all working in harmony.
It really is.
And, remember those equations we mentioned earlier? This document is packed with them.
Oh, yeah.
They're the unsung heroes behind every curve, every gradient, every, perfectly smooth transition.
It's amazing, isn't it?
I have to admit, when you first mentioned equations, I thought, oh boy, here comes the math. But you explained it all so clearly, and now I'm kind of fascinated by how much precision goes into something we usually just take for granted.
Yeah, it's proof that even the most, mundane things can be fascinating when you dig a little deeper.
This deep dive has definitely made me appreciate the invisible world of engineering that keeps our trains rolling smoothly. I'll never look at a train journey the same way again.
Me neither.
Well, that wraps up another fascinating deep dive. Thanks for joining us as we explored the intricate world of railway design. Until next time, keep those wheels turning.